Hello and welcome to my science tutorial. In today's video we are going to be looking at equilibrium on an inclined surface. So without wasting much time, let's get started. So an inclined surface is just let's say we have two wood, okay, and then we have one laid horizontal and then another one lean against it at a particular angle. So we have an angle, let's say theta over here. Okay, so this can be an inclined surface, or this is an inclined surface. Now assuming we have a body, okay, which is at equilibrium on this surface over here. Let me bring it down a little. Okay, so assuming we have this surface at equilibrium on this plane, there are some forces that act on this body once it is on equilibrium. Now first of all, we have our normal reaction, which will be acting upwards on this body. So and it will be equivalent to another force acting downwards, which is what? The product of the weight, which is mass times gravity cosine theta, the angle we have over here. Now our weight to act perpendicular downwards, okay, so our weight is what? Mass times gravity. Now there is, assuming this body were to try to move, okay, there will be a frictional force that will oppose the flow of this body, and then the frictional force, there is another force acting in the opposite direction of the frictional force, and that is given to us by what? The product of the weight, which is mass times gravity sine theta, the angle we have over here. So in these cases, okay, in this example, these are the forces that act on any body on an inclined plane. Now let's look at some few deductions that we can get from this. Okay, now we know frictional force is proportional to what? The normal force which we have over here. And whenever we remove the proportionalities, and we tend to introduce a constant which we call the coefficient of friction. Now this coefficient of friction, the u we have over here, okay, let's try and make it the subject in this case. So if we make the coefficient of friction the subject, it means we have frictional force divided by the normal. Now from this example, we have our frictional force to be equal to what? What we have over here, which is what? Mg sine theta. Then we have our normal reaction, which is R, to be what? Mg cosine theta. So if we bring this back and we have Mg sine theta divided by Mg cosine theta, it means this will cancel out, and then sine theta over cos theta from trigonometry, you know, will give us what? Tan theta. So it means our coefficient of friction u can also be said to be what? Tan theta. So assuming you are to find the coefficient of friction and you know the angle, but then you don't know the mass of the object, and then gravity we know is 10 or 9.8, but then you don't know the mass, so you can use the gravity and then the angle to find the frictional force, and then the normal force, and then find the ratio to find the coefficient of friction. You can use tan of the angle to get the coefficient of friction, and then you continue your calculation in any way you want. Now this is for the first case, so let's try and look at other cases on an inclined plane as well. Okay, okay, so if we have this same body on an inclined plane, and then in this case, assuming this body is about to slide down, okay, and then we need to apply a force P horizontal to the surface to keep this body at equilibrium, things now changes. We now have different deductions for this particular example. So if we apply a particular force to keep the frictional force from pulling down this object down the inclined plane, our deductions from earlier now changes. Now we tend to have different horizontal and then vertical forces acting on this body. So let's have a look at the forces acting on this body in this example. So for the parallel forces, okay, forces that are parallel to the line, we can see that now we need to add the applied force with the frictional force to give us what? The force that is preventing this from coming down. So for the parallel force acting along this line, we have P, our applied force, plus the frictional force to give us what? Mg sine theta, and this holds true. Now for our perpendicular forces, that is the forces acting downwards, our perpendicular forces, okay, we can see that there is only one perpendicular force acting downwards, which is the weight cosine theta. Okay, so which it will be equal to what? R is equal to what? Mg cos theta. So this is the case assuming we apply the force horizontal to the plane. So these two equations are really important, so let's take good note of them. We will be using them in some calculations that are coming after the third scenario in this tutorial. So with this done, let's have a look at the third case for inclined planes. Now let me get rid of this as well. Okay, so assuming the force we are now applying to hold this body in equilibrium is applied at a particular angle, okay, to the body on the plane, then things now changes. Now whenever we apply a force at a particular angle, it means if I draw the horizontal to that plane, okay, it means we have an angle here, let's say alpha, okay. So this force will now tend to have what? Vertical and then horizontal components, okay. So if I redraw everything I have over here, the applied force, just like as a way of magnifying it, the applied force P at a particular angle, and then we have the horizontal and then the vertical components of that force. This is way too long. This is way too long. Okay, so if we have this at an angle of alpha, this is just a much bigger view of what I drew over here, okay. So it means the horizontal force that we have over here will be what? P cos alpha, and then the vertical one acting downwards will be what? P sine alpha. Now if this we have over here is what we have over here, now let's look at the parallel forces in this case. Now remember in the first example, we have our parallel forces to be what? F plus P to be equal to what? Mg sine theta. That is in the first example. But then in this example, our P is not applied horizontal, it was applied at an angle, so we need to include the angle as well. So in this case, the parallel force, okay, in this example will be the horizontal one over here, which is what we have over here as what? P cos alpha. So if this is true, it means our P over here will not be this normal P again, then everything over here will change to what? F plus P cos alpha for the parallel forces. Now for the horizontal for the perpendicular forces, that is forces coming downwards, okay. For the perpendicular ones, for the perpendicular forces, then we tend to have something different. That is, for the perpendicular force, we know R, okay. In the first example, we have R to be equal to what? Mg cos theta, okay. But now, because we now have another force acting downwards, which is the one over here, okay, we have another force acting downwards. It means it is not only the Mg cos theta that is acting downwards, we have another force which is P what? Sine alpha, also acting downwards. So in this case, this will no longer be the case for the perpendicular case, okay. So this will no longer be that of the perpendicular case. The perpendicular case would now be what? R is equal to what? Mg cos theta plus the second force acting downwards in this case, which is what I have over here, okay. So plus what? P sine alpha. So this will now give us the overall total forces acting perpendicular to this object on this plane, and then this we have over here will give us the overall forces what? Acting parallel to the plane. Now if we have all this formulas quoted or jotted somewhere down and we've understood the explanations I've given so far, let's have a look at some practical examples to actually further enhance our understanding about forces on an inclined plane. Okay, so let's have a look at example number 1. So example number 1, we have a particle of mass 10 kg is placed on an inclined plane at an angle of 30 degrees to the horizontal. What force acting parallel to the plane is required to 1. Hold the particle at rest, 2. To just make the particle move up the plane, then we are given our gravity to be what, 10 meters per second square, and then our coefficient of friction to be 0.4. okay, so let's solve this solution. Now first we need to draw the diagram for this case. So we have our inclined plane at an angle of what, 30 degrees. Then we have our object over here, so which means we have our normal reaction acting like this, our frictional force in this direction, then we have our mg sine theta over here, then we have our mg cos theta acting downwards, then we have our weight. So I will ignore that in this case. So they are now asking us, okay, what force acting parallel? Now parallel means we are applying a force directly parallel to this plane, okay, and it is pushing this upwards, so P. Now what force acting parallel is required to hold the particle at rest, okay, so I. To hold the particle at rest, we know from the scenario I gave first, it means we have to add P plus F, and this should be equal to what, mg sine theta. Okay, so if we make P the subject, because we have to find the force that is required to hold, so it means we are going to make P the subject. So this will be what, mg sine theta minus F, and we know that what, F frictional force is equal to what, coefficient of friction times R. Okay, so in place of everything over here, the F over here, we can write what, mu R. Now we know that we still have this, okay, now minus mu. Now the R, which is the normal reaction in this case, because the applied force over here is just horizontal to the plane and not at an angle, our R will be equal to what, mg cos theta. Now if we are all on the same page over here, we can now go ahead and find our force that is required to hold the particle at rest, which is the P. So P will now be equal to what, the mass of the body is 10 times the gravity given to us is 10, then sine 30 minus 0.4 into bracket, this will be 100, which is the mass 10 times gravity 10 is 100, then cos 30. Okay, so if we punch this straight away into the calculator, we will be getting 15.358, which means our force that is needed to hold this body, okay, at equilibrium on this plane in this example is what, 15.4 newtons. Okay, so this is how we solve a problem on an inclined plane if we are given and then the surface we are dealing with is what, rough, and it is not smooth. Mind you, if the question were to state that what, the horizontal, the inclined plane over here is what, smooth, it means our frictional force would have been equal to 0, so we will not be deducting the frictional force from the mg sine theta over here. So let's take good note of that. So with this being dealt with, let's look at the second aspect of the question. So let me just get rid of everything here. Okay, all right, so oops, wrong color. Okay, so the second aspect of the question is asking us to find the force just to make the particle move up the plane. Okay, so if in the first case, to make the particle at rest, we subtracted, we had what, P is equal to what, mg sine theta, if you remember, then minus frictional force. Okay, this is what is required to hold the particle at rest on this surface. For us to have this particle moving along up this plane, it means we need to add the frictional force to the force that we are applying, which is the P. So once we add this, instead of subtracting, okay, we will have our force being greater, and then it can move this body along the plane. So if this holds true, it means our force that is required, P, that is required to just move the particle up the plane, will be what? Mg sine theta, okay, plus into bracket mu mg cos theta. So this will be what? 100 sine 30 plus 0.4 100 cos 30. Okay, if we input this into the calculator, we'll get 50 plus what? 34.64. so overall we will be getting what? 84.6 Newton. So this is the force needed to move the particle up the plane. Now let's look at something. If this is the force needed to move the body up the plane, and then in the first example we had our force to be what? 15.4 newtons. Okay, it means if we compare these two forces, it means the force that we need to just hold this body up this plane is very less, okay, 15.4 newtons. But then if we want to actually push this object up the plane, we need to apply a much greater force to push the body up the plane. Okay, so this is how we solve examples on questions in this form. Okay, so if you are asked for the force that is needed to just hold the body on an inclined plane, you need to subtract the frictional force from the mg sine theta. But then the force needed to move the body up the plane, you need to add the frictional force to mg sine theta. So let's have a look at another example. Alright, example number 2. This will be very quick. So we have a particle of mass 5 kg is placed on a smooth plane inclined at an angle 30 degrees to the horizontal. What force acting parallel to the plane is required to hold the particle at rest? So let's write solution. Okay, we have a particle of mass 5 kg is placed on a smooth inclined plane at an angle of what? 30 degrees. So we have an angle of 30 degrees, and then the surface is very smooth, and then we have a body of what? 5 kg. So it's 5 kg. So normally as usual, we have our normal force acting downward, we will have our mg cos theta over here, we have our mg sin theta over here, and we have our frictional force acting in the opposite direction. Okay, so if this holds true, now let's look at how we will solve this example. So the question is telling us what force, okay, acting parallel. So the P that we will apply, okay, that is required to hold this particle at rest. Okay, and we know that what the force needed to hold this particle at rest will be what? P is equal to what? Mg sin theta, okay, minus what? Frictional force. That is the force that is needed to just hold the particle. If the question were to access the force that will be needed to pull the object along the plane, we would have used plus instead of minus over here. Now there is another interesting thing about this question. Can you see we have a smooth inclined plane over here? Smooth inclined plane. Okay, the fact that the plane is smooth means our frictional force is equal to 0, like I said. So it means our P over here is just equal to what? Mg sin theta, okay, minus 0. Okay, so this becomes like it is not there at all. So we have our force needed to just hold the body on this plane to be what? Mg sin theta. So from here we can go straight away. We multiply the mass with the gravity, which is what? 5 times 10 in this case, sine 30. So this is what? 50 sine 30, and then 50 sine 30 will give us a force of what? 225 Newton. So the force needed to hold this particular object, okay, at rest on this inclined plane is 25 newtons. So thank you so much for watching. I hope you've learned something, and then this helps you facilitate the way you see problems on what, an inclined plane. So thanks so much once again for watching, and then if you are new to this channel, my science tutorials, kindly consider subscribing as we post daily videos on what, physics, mathematics, biology and chemistry. So thanks so much for watching. If you like the video, kindly press the thumbs up button and then subscribe. It is really important for us. Okay, so thanks again, and then I'll see you in the next video. Bye bye.